So function composition, basically instead of, just adding things together and combining your like terms or multiplying things together, what you're actually doing is taking one function and putting it into the other. So the notation looks a little bit odd, particularly in my opinion, the one on the left. I like to call that fog notation. So how that's actually read is f of g of x. So it's the composition of f with g. So basically what that's saying, the one on the right, in my opinion, looks a little bit nicer, makes a little bit more sense. What you're doing is you're going to take your entire function, g, whatever it is, and take it to your function f, and wherever you saw an x in that original f function, you replace it with the entire g function.
Is that kind of like what we did with the f and the...
All of this is exactly what we did in algebra too.
Kind of. It's similar to when we were finding the difference quotient. But yeah, instead of replacing it with the x plus h, you're replacing it with, like, could be a square root of x. It might be x squared plus 5. It could be really, really random stuff. And yeah, you definitely did see this in algebra too at some point.
Yeah, I was gonna say, I was like, I feel like I'm reliving algebra.
Oh, yeah.
Algebra too.
If I remember correctly, you actually see it a little bit in algebra 1 too.
I wouldn't
Wow.
remember it except for the fog.
Yeah, fog notation is kind of distinct.
Oh no, I like this.
Because yeah, this is one of the few times that you'll see that like little random open circle.
Yeah.
It doesn't show up very often.
Looks like
Wait a minute.
It looks like what?
Looks like so
I like the new stuff.
Katie, remember
Can you
this
see
science class where you and Tyler and I always had trouble with that?
All right, so just like with our combined functions, we're still worried about domains because anytime you're messing with functions, you kind of need to worry about what you're actually allowed to use for your x. So how do we actually figure out the domain? So what you do is you look at first, okay, what actually works for g? So that function that you're replacing in, what actually works there? Because if something doesn't work for g, we have to exclude it from f of g. And then you also look at, all right, what works kind of within that simplified f of g. So we have to look at which values here, our g of x, actually work in the domain for f. So that's where it gets slightly odd, but you've got to kind of worry about your domain in two different places here instead of just kind of overall.
I know, I actually gotta go.
What?
I have a drug tester, sorry, I actually can't go.
Nah, he won't be bad.
Nah,
He never gets me.
yeah, he's been dead, he'll understand.
The only reason I found out about the speech to me was because I asked him to go to school.
I asked Mr. Sark, he's like, yeah, it's really Thursday. And we're like,
Oh, is this a rescheduled from our cancel?
We almost went the entire season just about the snow day cancellation. That would have been the first year.
Considering we had 10 snow days, that's pretty impressive. That none of them happened to be, or I should say only one of them happened to be a day you guys had.
It was really weird though, because it was like Thursday and I wasn't at school and I wasn't in Pacific for speech to meet. I was like, this is not right.
Oh, are they traditionally on Thursdays?
Yeah, they're always on Thursdays.
Remember the other day?
Wait,
Yes,
I don't think so.
I did my, I need all of them, I think, one.
Hey.
I always get note cards. I never use them. 'Cause you don't use note
All right,
cards.
so just a little bit more specifically about finding that domain, because like I said, it's a little bit more complicated when you're working with a composition rather than just a combination. So what you need to worry about, again, we're kind of more worried about what doesn't work. So you need to exclude any values that are not in the original domain for g of x. So if g of x is a polynomial, you don't have to worry about anything. If g of x has a fraction in it, you need to worry about a 0 in the denominator. If g of x has a radical in it, you need to worry about taking square roots of negatives. So start by excluding any value that's not in your domain for g of x. And then once you figure out those, you also need to exclude any x's where it makes it happen to where g of x won't be in your domain for f. So you again need to worry about, if f is taking g and putting it into the bottom of the fraction, now what's going to make that denominator 0? Or if it's putting it into a radical, what's going to mean that I'm taking the square root of a negative? So it's really easy to kind of forget about that second component. So make sure first you look for what's going to screw up just g of x, and then what values from g of x could screw up your new combination. All right, so here we've got a pair of functions, and we're going to find three things. We're going to find f of g of x, g of f of x, and f of g of 2. So our first pair, we've got f of x, which equals 2x, and g of x, which equals x plus 7. All right, so for the first part, we're going to find f of g of x. So if you like I said, what I call the fog notation, you're welcome to write it that way. I would say it's probably easier for you to write it this way. I really don't care which. They're completely equivalent. So whatever floats your boat, and like I said, in my opinion, this one makes it a little bit more clear what's actually going on. So what is g of x? Well, it's x plus 7. So what we're going to do is take x plus 7, and wherever we see an x in our original function f, we replace it instead with x plus 7. So we're going to be taking the x plus 7 and replacing it right in there for our x. So we would end up with 2x plus 14.
And that's all we do, except for like the denominator or the
Domain?
Yeah.
All right, well here we're not actually asking about the domain, but we're going to talk about it anyway. So for g of x, what would its domain be? All reals. Yeah, it's just a normal polynomial. Everything's all good. All right, here, what would our domain be? All reals. So it's all reals for this guy.
So we don't have to look at the f function at all to see if it's all reals too.
You only worry about g and then that simplified version. So now we're going to look for g of f of x. Okay, so in this case, we're instead going to take f of x and substitute it into our function g. So should we expect to get the same thing? No, it's possible, but unlikely. So there will be rare occasions where it does work out the exact same, and we'll talk about why that happens later. But if it doesn't, fret not. It's more common for it not to than for it to actually work. Okay, so for the domain on this one, what would our domain for f be? All reals, and then if we look at the 2x plus 7, all reals. So this one would again be all
Always be the
reals.
same.
What do you mean, the domain?
Yeah.
No, not necessarily. All right, so then we've got one more thing we need to find. We need to figure out what is f of g of 2. Okay, so that's the same as writing it like that. So we've got two options here. What you could do is you could take a 2 and put it into your g function, get some number, and then put that into your f function. Or, if you're feeling confident about your earlier work, we already figured out what f of g of x is. So if we want to know what f of g of 2 is, we can just put in 2 to that function, and we should get the exact same value. So for this first one, we'll check it both ways. You don't have to normally do that, though.
On the B part, like, sorry, I'm going back after.
Oh, no, that's fine.
But why did you put the G first? Like, on the second part, why'd you put G and then 2x?
Because here, what we were trying to find was g of f of x. Here, we were finding f of g.
Okay.
So because those, what we're actually looking for switched, that's why we switched it. So we have to pay attention to the order that's given to us.
So whenever you do what we're about to do next, you actually get a number.
Right, we're gonna get an actual number because you don't have an x anymore, you're replacing it with some value. Alright, so like I said, we could say, alright, I'm gonna put in 2 to my g function. So if we put in a 2 here, what would we get? 9. Okay, so now that means what we're really looking for is f of 9. So if we put in a 9 there, what do we get? 18. Okay, so f of g of 2 is 18. How else could we find that? Well, we found f of g of x, which we said was 2x plus 14. So if we want f of g of 2, so I lost a parenthesis, we can just replace that x with a 2. Well, 2 times 2 gives 4 plus 14 will give us that same 18.
So do we have to keep writing f of g of x and stuff, or can we just like write f of g of 2 and then solve it like
That's fine.
that? Okay.
Just for me, I feel better having to but that's okay.
Alright.
Alright, so again, you don't have to show it both ways. There are kind of benefits and disadvantages for both of these. This method's going to take the image a little bit longer, not that big a deal. But the issue is if you use this one and you messed up when you found f of g of x, your f of g of 2 is not going to be right. So again, if you're feeling confident that this all worked out okay, I would say go with this method. It's going to be a little bit faster for you. But again, if you make a mistake, it's going to compound over here and you're going to have problems. So any questions with our first pair of functions here? Alright. So those were pretty basic functions. Let's step it up a little. So same thing, we're finding f of g of x, g of f of x, and f of g of 2. But this time, our f of x is x squared plus 2, and our g of x is x squared minus 3. So if we're first looking for f of g of x, that means we're going to take our x squared minus 3 and put it in to x in our f function. So we're replacing x with the x squared minus 3. So we would have x squared minus 3 squared plus 3. And yes, we need to simplify that.
Plus 2.
It totally would. I have no idea where that 3 came from. Thank you. Oh, goodness. Try that again. All right, so yes, we need to simplify that. So if we're going to take x squared minus 3 and square it, what do we need to remember to do? FOIL, yes. So if we FOIL that, we'll get x squared minus 6x plus 9. So don't just give me x squared plus 9. That's not quite right. And then we've still got that 2 trailing.
Wouldn't it be x squared?
Yeah.
It totally would, and x squared. Oh my goodness. I treated it like